Okay, good morning class. So today we're looking at trigonometry. I gave you some homework. The homework was on exercise 5.3. Was there any issues with the homework? Yes, okay. Okay, we'll sort that out and then we'll do the examples for exercise 5.4 on page. Okay, so let me just take this down here. So now we're looking at the examples for exercise 5.4, and 5.4 is on page 112. 5.4 is on page 112. Okay. However, these examples is on page 111. Example page 100. Okay, so say we got sine of 50. Put sine of 50 in your calculator. Sine of 50, what do we get? 0,77. Now if you say arc sine of sine of 50, now put that in the calculator. Arc sine, shift sine, sine of 50. What do we notice? Error. It's 50. So what is arc cos? Arc cos of 20. Arc cos of 20. 20. So what do you think arc tan of 70 will be? 70. So by saying shift tan or arc tan, you're actually reversing whatever the function is doing. You guys understand? So for addition, what's the opposite to addition? Subtraction. What's the opposite to square root? Square root. What is the opposite to cube? Cube root. What's the opposite to division? Multiplication. So the reverse of sine is arc sine. The reverse of cos, arc cos. The reverse of tan, arc tan. You guys understand? Okay. So now we are told that sine to the minus 1 cos, or arc sine, arc tan, and arc cos are key inverse function keys, and to calculate the angles that gives a particular ratio. Okay? Angles that give a particular ratio here. So let's look at example 1. And example 1 is on page 111. The question says calculate the value of the following. It says use your calculator to find the value of theta between 0 and 90. Correct to one decimal place for 4 sine theta is equal to 1. Okay, for 4 sine theta is equal to 1. So my first step is to get that sine. We must get the ratio on its own. That's the first thing I need to do. At that point I can't say arc sine both sides because there is a 4 in front of sine. You guys understand? So what do I do first? I would divide it by 4 both sides. So dividing that by 4, I would get sine of theta equals 1 over 4. So what do I do now? Now I can apply that arc sine slowly, not so. So I say arc sine, sine of theta is equal to, remember I've added arc sine to the left hand side, we'll add arc sine to the right hand side as well. So what is arc sine, sine of theta? What do you think? If arc sine, sine of 50 was 50. So arc sine, sine of theta is theta. So you put on your calculator, arc sine of a quarter gives us 14,5. 14,5.
So it wouldn't be 1 decimal.
Most of the times one decimal, if they don't specify, you can do 2 or 1. But if they specify 1, you give 1, if you specify 2. Okay. Yes?
Why are we adding the oxide?
Sorry?
Why is it adding the oxide?
Because that's the reverse of sign. Okay, remember if you got 2x is equal to 5, how do we get x on its own? You divide it by 2, not so? So that cancels, so x equal to 5 with 2. So, if you got x plus 1 is equal to 4, what do we do? X is equal to 4 minus 1, which is 3. So what do? We apply the inverse function. Can you see that? And what is the inverse function to sine? Arc sine. But remember, in an equation, what you do on one side, you must do on the other side. So why am I adding arc sine? To get rid of that sign. But if I add arc sine on the left hand side, must add arc sine on the right hand side as well. Okay, just to keep the equation balanced. Okay, it's basically the inverse operation. Anything else? Alright, let's go to the next question. This is the next example, which is also on page 111. It says, use your calculator to find the value of theta between 0 and 90. Correct it one decimal place with tan of theta minus 25 is equal to 0,465. Okay. So the first question we're asking ourselves, is tan on its own?
Yes.
Yes, so tan of the angle. Now, in our last lesson, we indicated that I can't multiply tan out using the distributive rule. I can't say this is going to be tan of theta minus tan of 20. People, that is not right. Okay? You can't touch that angle. Okay? You can't break up that angle. You can't apply the distributive rule. Okay? Because the tan sign and cos of functions, and there's a function on that theta minus 25. So how do I get rid of this tan? Arc tan both sides. Can you see that, people?
Yes.
So what is arc tan of theta minus 25? Theta minus 25. You will understand. What if this was a cos here? Then what would I have written here? Of cos. You guys understand? If there was a sine here, then I would have said arc sine. You guys understand? Let's just take its inverse. So since I added arc tan on the left hand side, I must add arc tan on the right hand, the reverse of tan. Okay. So of course this cancels, leaves you with theta minus 25 equals. Put the other calculator arc tan 0,465. What do you guys get? 24,94. So what do I do now? Take the 25 over the equal sign. So theta is equal to, let's say plus 25, 49,9. 49,9 degrees. Okay. See, any confusion here? Also, within the sum, when we're working with the sum, we work with more than one decimal place. Okay? When it comes to the final answer, we give it in one decimal. Okay? You all okay with that? Look at the third example on page 111. Again, I don't know if I told you earlier on that for grade 10, we're working out the angle will always be between 0 and 90 degrees. We come to grade 11 and 12, then we speak about the angles outside the first quadrant or outside that given the restriction of 0 to 90. Okay. So for now, you always see it's always from 0 to 90. Right, the question reads, use your calculator to find the value of theta between 0 and 90 degrees. correct to one decimal place for cos of 2 theta minus 10 divided by 2 is equal to 0,091. So the question is the trig ratio on its own? So what do we have to do first?
Times 2.
Times by 2 both sides. You all understand? Right, so you times throughout by 2. So if I multiply that by 2, that cancels, not so. So it's going to be cos theta minus 10 is equal to, now you put on the calculator, 0,091 times 2 gives us 0,182. Okay. Now can I take all cos on both sides? So take all cos quickly. Okay, so what do we say is arc cos? So on the side I'm also going to have arc cos. Okay, you all agree with that? So the cos is cancelled, so 2 theta minus 10 is equal to, on my calculator say arc cos, that answer is the last answer calculated, give you 79,51. You all agree with that? Huh? 79,5. So what do I do now? Take a 10 over the equal sign. So it becomes 2 theta is equal to 89,51. So say plus 10 here. Then what do we do? Divide by 2. So it's 44,76. So it's 44,8. Okay. Is there any confusion? Nothing really? Why you look like it? Were you young on Friday? Who was? My cousin? Children? Were you here? Did we eat Friday or did we? Sorry? It's common. You know it's a common. Do you know or don't you know it's a common? Yeah? You do know? You just want to talk to me a little. Okay, any confusion? No, alright. Now I'm going to look at the example on page 112. On page 112. It says use a calculator and solve for theta correct to one decimal place with the restriction that theta is greater than 0 but less than 90. It's the same thing what we had in the previous question. Here they just gave it to you in inequality format. Okay. So the question you have is tan theta plus 1. Tan theta plus 1 is equal to 2. Do we have the trig ratio on its own? Can I take arc tan as it stands? No. What's the problem? The plus 1 is the problem. So what we do is we take it over the equal sign. So tan of theta equals. Can I apply arc tan now on either side?
Yes.
So do your thing quickly. Now we go. arctan of 1. That cancels, so theta is equal to arctan of 1 gives you 45 degrees. Do we all understand? Is there any confusion? No. Okay. So with that, you should be able to do exercise 5.4. We'll do exercise 5.4 quickly.